Why can't I see through this piece of paper, even though I can see through this piece of glass that's 20 times as thick? What if I told you the answer to this question can help us understand how light interacts with gas in our atmosphere to produce the greenhouse effect, and how the greenhouse effect would change on a different planet with different things in its atmosphere? You're probably familiar with carbon dioxide, which is a gas that absorbs infrared radiation. Carbon dioxide only has 400 molecules per million molecules of air. So how does it have such a large impact? Let's go back to my first question. Why can't I see through the paper that's thinner than the glass? The paper absorbs visible light. It's opaque. The glass is transparent to visible light. It lets it through. How solid materials interact with light depends on the color of light we're thinking about. For example, this blue filter lets blue light through and blocks red. And this red filter lets red light through and blocks blue. Now, if we use our imaginations, we can think about light that's redder than the light we can see. That's called infrared light, and we can sense that as heat. In infrared light, actually this piece of glass is just as opaque as this piece of paper. And if we can draw an analogy between these materials, solid materials, and the gaseous materials that are in our atmosphere. For example, the oxygen and nitrogen that constitutes the bulk of our atmosphere is transparent in both visible and infrared, like this glass is transparent in the visible. The carbon dioxide, on the other hand, is opaque in the infrared, like this piece of paper is opaque. Now, if we take this further, we can imagine that the Earth is emitting infrared radiation to cool off, right? But the carbon dioxide forms a layer that blocks some of that light from escaping to keep it warm. Now, let's take this a little bit further and do a thought experiment. Let's take the Earth and move it away from the sun with an interplanetary tugboat. Let's move it so far away that we freeze out that carbon dioxide in the atmosphere to a layer of dry ice, or carbon dioxide ice. How thick would that layer be? Actually, that layer would be about 3.8 millimeters thick, which is 30 times thicker than this piece of paper. So if we can imagine this piece of paper blocking a lot of visible light and being completely opaque, we can definitely imagine something that's 30 times as thick blocking a bunch of infrared radiation. We can even apply this to other planets in our solar system. Venus, for example, has an atmosphere that's almost 100 times as massive as the Earth's, and it's almost entirely carbon dioxide. If we did that same experiment with Venus, how thick would that ice layer be? Actually, it'd be 900 meters thick, almost a kilometer. So it's easy to imagine Venus trapping a lot of infrared radiation and explaining why its temperature is 460 degrees Celsius at the surface, hot enough to melt lead. So next time someone asks you about the greenhouse effect, think about the paper and the glass. Thank you.
Okay.